Okay, Assalamu alaikum. Welcome to this chapter 8, week 10. This is about, we are going to study something about routing. So let's just remember what we have learned about local area network. Okay, we said local area network covers small geographical area. Okay. And LANs are usually wired or wireless. Here we have an example. How many LANs we have in this drawing? Can you see it? 1, 2, 3. We have 3 LANs. So we have 3 broadcast domains. So it's always better to segment your LAN, segment your networks. يعني تقسيم, segment يعني تقسيم النetworks. As you can see here, we have one lab here, we have switch there. So we are segmenting, dividing it into segments. Why? It is appropriate for simpler networks. It is less complex, and it is faster bandwidth, faster data transfer, and easy of device access. Okay, so it's more logical. What are the disadvantages? All hosts are in one broadcast domain. And here, this is only one broadcast domain. Okay. It is harder to implement QoS, and quality of service, and harder to implement security because they are in one broadcast domain. Remote network segments. So advantages of having hosts on a remote segment, as you can see here. This is my router. Here I have host on some remote segment. Okay. So it's more appropriate for larger, more complex networks. Split up networks domains and decreases traffic. Can improve performance on each segment and makes the machine invisible to those on other local area networks. And what we would like to say here is, it's always not good. Let's say I have my network, okay? And this is a switch. Let's say I have 100 computers. I have 3 stories, 3 floors, like here. It's not good that I connect all the floors to one switch. This is not good. It's better you install 3 switches, okay? So let's say you have floor 1, floor 2, floor 3. So you will add a switch here, switch 3, switch 2, switch 1. Okay. You connect all the computers on first floor to switch 1, all the computers in switch floor 2, and this floor 3. And each switch is connected to the other switch on the backbone. This is better. We call this segmentation. But all of them are one broadcast domain because all of them will be connected to one router. Okay? So they are all broadcast domain. Why we do this? Simpler management, more efficient. It will improve the traffic for each floor. Okay? Is it easy now? Understood? And we can see it in every classroom. We have also access. So the criteria is you have broadcast containment. If we look here, please, question here. How many broadcast domains do I have? 1. Very good, because you are connected to one part of the router. What about here? Same. 1. Okay. So here we have broadcast, any traffic here cannot be broadcasted outside. It will go through the router. So it's good for containment of a broadcast, also for security, because your router is your gateway. It will protect the internal traffic from the outside. Location, if I have two sites, let's say I am a bank. I have another location in another city, so I can put a router. I can put a site there and a site here in the headquarter, and I link them through the WAN. The red link here is a WAN link. Also, it's good for logical grouping. You can group engineering, distribution, finance, accounting, like that. So we need routing. Okay. First, let's understand the switch. We said the switch only understand MAC address or physical address. Okay, such as here, BBB or AAA. So your packet will have source, destination, and source of MAC address. Then it will have source IP and destination IP. Okay. The switch will only check the MAC address. Okay. The router will check the IP address. So your IP address, this is your complete IP address. The first 3 octets, these are the first 3 octets. This is your network portion. This is your network address. And this is your host address or computer address. Okay, so if I have, let's say I have this address, 192.168.20.5. What is my network address? Network address. This part. Why? Because this is class C. What is my host address? This one. We are refreshing your memory about the class A, class B, class C. Remember the classes? Class A, the network address will look like that. N, then H, this one. N, then H, host, host. This is class A. Class B, N.N, بعدين host. Class C, the one mostly used, is N, H. شو يعني هذا جزء for network. The last one is host. Here, no, the last 2 parts are for host, and the first 2 parts are for network. I'll tell you something. Sometimes you go to some buildings, they will give you a number. The first 2 numbers are for the floor number. The last 2 numbers is the flat number. Or in the hotel, sometimes like this. Yes. They will give you like, your room number is 2022. So the first 2 digits is for the floor, the last 2 digits for the room. Same thing here. But we have different type of classes. Class A is the first number is for the network, the other part is for host. For example, we have 10.1.2.1. Class B is NN, like this is 172.16. Okay. .5.1. Class C is like 192.168.1.10.1. Okay. Understood? Any questions? We continue. Okay, so here we have a router. The router will decide if the packet is going to go outside the local area network, or it will stay in the local area network. This is decided by the router. And the router, to do that, it will check the IP address. Okay. Routers do not forward broadcast messages. The destination MAC address is used to forward the packet to either the router if the destination IP address is for a different network, or if it is a specific network device on the local network. Okay. The ARP table shows a mapping of IP address to MAC address. The ARP table will map IP address to MAC address. This is used by the switch. So inside the routing table, if you go to your router in the packet tracer when we do the lab, we can issue a command to see the routing table, show IP route, to show my IP routing table. You can see different letters, okay? It will show you what is directly connected, what is a static route, what dynamic routes do you have, what default routes do you have also. Dynamically learned from other routers or manually entered by the administrator. A default route is the router interface used when forwarding packets to a destination that is not in the routing table. If a packet is destined for a network that is not in the routing table and no default route exists, the packet will be ignored or dropped. يعني إذا أنا الباكت إجتني, I don't have any information where to forward it, and I don't have any default route, that will be dropped. Okay. Default gateway is where everything will be sent to it. If it is going outside the network, nothing can go outside the LAN without going to the gateway. We know about gateway before. So routers, they are used to connect LANs, and each router interface will have a LAN connected to it. Okay. And the gateway, this router interface is the gateway to that network. We learned that before. A wireless router commonly provides IP addressing information for local internet hosts. A router that connects to the internet commonly gets addressing information using DHCP from the internet provider. This is for the wireless router. Okay. So this is your wireless router. It will get the information using DHCP from the internet provider. But what is NAT? NAT is used to convert private address used within a company to a public global address that can be routed onto the internet. And here, you see here, you have 192.168.1.3. Other address is private. This cannot go to the internet. And NAT will translate this to an address that is understood by the internet. Public address. This is done by the NAT. Okay. And one public address can be shared among many private IP addresses through the use of port numbers. So NAT was used for a long time now, but NAT causes latency and limitation. That's why now they are using IP version 6. IP version 6, everyone will have IP address. It's faster. Okay, and for IoT, is using IP version 6. IP version 6 has 128 bits. Okay. And each bit, and it is written as 8 blocks of hexadecimal numbers, separated by colons. Okay. Dual stack allows IP version 4 and IP version 6 to exist in the same network. Okay. And dual stack device run both IP version 4 and IP version 6 protocols. All right. This is a dual stack, يعني بيشتغل عليه 4 or 6. Another way is to use tunneling. يعني here I have IP version 6, here I have IP version 6. I can have a tunnel for IP4 only networks. This is another way to write the IP version 6 address. For example, this number can be written as, so we remove the 0. And if I have this all zeros, I can put 1 0 only. And if I have 0 200, it can be 200. Okay. Also, if I have a group of consecutive all zeros, then I can put double colon. Okay, so here we have, you see here, 0 zeros here. I can just put double colon. And thank you very much. Now I'll stop here. If you have any